Hi, this is Ravi Uzarkar, and today I'm going to talk about the moving load generator inside GT Strudel 41. So here on the screen, you see a diagram of a moving load on top of a steel beam. The steel beam has a wide flange shape or I shape, and this is shown to you in elevation. This beam needs to be designed for this moving load, so we are not sure about what are the maximum moments and the maximum shears for which this beam needs to be designed, depending on the position of this moving load, which is a little bit complex. So without a computer program, this is going to be very hard to solve by hand or any other means. So let's see how GT Strudel can help you out to design these types of structures. It could be a crane beam, a bridge, or anything on which a moving load is going to be present. Okay, so let's first dive into the interface of GT Strudel. So let me minimize this PowerPoint, and I'm going to go in and launch GT Strudel 41, which is the current version of GT Strudel in year 2023. When I launch GT Strudel, first you will see a welcome screen, and you can basically choose which interface you want to use for generating your moving load. Okay, so I'm going to use the GT menu interface first to generate my geometry. Okay, so we're going to start off with the blank slate, nothing really constructed in this model. But if you wanted to see the moving load in action, you can click on Help, Example Models. And here there's an option called Curved Bridge, and this actually uses the moving load generator, okay? But I'm not going to go and open that up. I'm going to create a structure from scratch inside this interface first, okay? So if I go to create a model wizard, first I'm going to go in and create a space frame structure. Um, let's just say we're going to create a structure using the feet and the kip unit system. Click on next. Uh, I'm going to accept the y-axis as the axis of gravity. That's fine. Uh, in this case, we're just going to make a very simple structure. So I'm just going to minimize, just put in 1 as the number of floors, 1 as the direction along the x-axis, and along the z-axis, okay, I'm going to leave that as 4. Click on next. Each floor is, let's say, 12 feet, and the length along the x direction is, let's say, 25. Along the z direction, I'm going to put it as 30 feet. Click on next. I'm going to accept these defaults for steel beams. That's fine. I'm also going to generate self-weight loading. Click on next. I'm not generating any loadings on the beams, so let's just click on next. No wind loads. Next. I'm actually going to create physical members. You can run the analysis if you like, but I'm not going to do that right now. Hit finish, and it basically generates a geometry for you in the graphics, okay? Now, if you click in the graphics and just press I on the keyboard, it'll give you an isometric view of the structure, okay? Next, what we're going to do is draw some intermediate members, okay? Now, note that we actually checked that box called physical beams. So that means that now we have a physical model. So if I click on the mode bar on physical, I can see the physical model. And if I say analytical model, it shows me the analytical model. Okay, I'm just going to go to the physical model, and I'm going to explain you why generating in a physical model is better. It basically helps you out if you're integrating with other products like CADWorks or Smart 3D. Okay, so let's go in and create some additional members. If I go to create section properties, you can define additional section properties if you want, but we're going to utilize whatever there is there, okay, right now. Just going to minimize that, close that. If I go to create, place members, here we can go in and select the beam size that we just saw. Okay, we can just pick maybe any of these sizes. Then we can just say start in direction. Offset is going to be 5. Length is going to be 30. Along the X, we're going to create these along the Z direction, by the way. And we're just going to say number of copies is 4. And once that's done, we can just click on generate members and click on this node. And you see now it just created those infill members for you quickly, right? So what this allows you to do is draw multiple members, okay, very easily using the place member option, okay? But note, what's going on is we're actually connecting these members with these other members, right? We already have members defined. We're connecting new members to existing members, and it's going to create additional node points. But if you create additional node points, we don't want to lose the intelligence that, okay, this beam actually starts at this column location and ends at this column location, right? So we don't want to lose that. And that information is captured by physical beams, okay? Now you can right click in the graphics here and to finalize that drawing, and you can click on store, and it says, hey, do you want to keep the self-weight loading on the members that are going to be split? I'm just going to say yes, I want to maintain that. And as a result, now you see if you click on that beam member, it actually, or sorry, if you you may have to go to this query option and just select members only, okay? So if you now right click on this member, it selects the entire span, okay? Because right now you're in the physical mode. If you go to the analysis mode and do the same thing, it highlights the analysis member, okay? Okay, so we now are going to generate moving loads, okay? So that's our aim. If you go to display model and you click on supports, we already have supports defined, and you can just say mark supports. You can see where the supports are, okay? If you click on this button called redraw solid, it'll actually show you a solid view of the entire structure that we have drawn here, okay? Okay, now the moving load generator is not in the GT menu interface, so you have to go back to the shell mode to access that command, okay? So the way you do that is you could just save this file so that you don't lose it. So you can go to File, Generate GT STRUDL, Input File, Generate GT STRUDL Input File, and you could call it moving load, okay? And enter, you can double click on this file and you can see like the GTI file, okay, which is very like, you know, engineers, structural engineers know this language. Okay, this is called the STRUDL language. Shows you every single node coordinate in text format. You know, member incidences, member properties, and all your physical members, and even your load commands are shown here. Okay, so let's close that. I'm going to close this. I'm going to close the GT menu interface here. I'm going to maintain that. I'm not closing the file. I still have the file in memory. I'm just going to the GT shell mode. Okay, so this is the GT shell mode, which gives you access to some other commands like the moving load generator. So if you go to modeling, loads, and moving loads, here you can define the members along which you want to generate the moving loads. Okay, so you can just click on these three dots. Okay, you can go in and just say, hey, I want to do a graphical selection of the members or the beams. And let's just pick one line of members on which these moving loads need to be generated. Okay, so we can just pick maybe 24, 36, 44, and 52. Okay, let's click on OK. And let's click on OK here. Now we'll say on each member, we want to generate, let's say, 3 different stops, okay, of that moving load, okay? And then this is like the standard bridge loading type vehicle loading, okay, or truck loading, which is HS20. We don't want to do that. We are going to do like a user-defined loading, and we're going to define the axial loading. Okay, so the first load, we're going to put it as 10 kips. And we can see the unit system is on the bottom, right inside corner, feet and kips. I'm going to click on store. The spacing between the next axle is going to be, let's say, 8 feet. And let's say that that is going to be about 20 kips. Click on store. So now you see like it draws what the vehicle is going to look like, okay, or that moving load is going to look like. So we have 10 and 20 spaced at 8. And then we're going to do another one at 15, let's say at 4 feet. Click on store. And then we're going to do another 10 feet loading at, let's say, 10. Click on store. And we have that moving load, okay, which is pretty similar to what we had in mind before. Well, actually, I have an extra axle there, okay. Now, if you want to remove the previous one, you can just say remove last, okay? And then you can just say, hey, I want to put this one at 4 feet, store that. And the next one, we want to place it, let's say we're going to have a 15 kip loading, and we want to place it at, let's say, 10. You can click on store. So we have a similar looking moving load, okay? Now you can control the direction. You can control the direction of that moving load also. Like if we want to go forward in this case, the axis of gravity in this case is Y. So we want to create a negative Y. Sometimes engineers would like to take impact into account, so we can multiply that by an impact factor of 1.5. So the moving loads are going to get multiplied by 1.5. And the initial loading name, I can just call it moving load ML. And this will create multiple moving loads. Okay, so moving load number 1 will be like your first position, and maybe nth loading is going to be called 10th, you know. So we'll see what it creates, okay? Now, once you have filled in this dialog box, it'll actually show you the text format of that loading in the shell interface, okay? The shell interface allows you to learn the STRUDL commands as well. So if I click on OK here, you see all these moving loads are generated, and it shows you an echo of all the loads that are generated for you, okay? Huge time saver. So now if you go to modeling, graphical modeling or GT menu, this will take us back into the GT menu interface or the graphics. Again, click anywhere in the graphics, press the I button on your keyboard, or you can just click on View, Isometric View. Now, if you expand the loadings, see all these loads that are created? These are all the moving loads that were generated by the moving load generator. If you click on Analysis, Linear Static Analysis, Stiffness Analysis Standard, it actually analyzes all those loadings for you, okay? Click on Done. Now, if you wanted to see those moving loads, you can press this Display Load button. You can pick any of those moving loads, and you can just say Draw Load Arrows. So you see all those moving loads on the beam that we had put it on, right? So, but this is going to show you the different positions, okay? And then you can click on Draw Load Arrows. A better way to visualize these moving loads is to go to Results, Moving Load, okay? And here we can just press Control and click on the self-weight, okay? Because we don't want to visualize the self-weight loading, okay? But we want to see the moving loads, right? Here you can say Draw Load Arrows, so it just basically does the same thing that we saw before. But if you click on Draw Deform Shape, it'll actually show you the deformed shape of the structure also as this moving load moves across this structure, okay? Now, if you click on this Animate button, it'll show you a cool animation of how the structure responds depending on where the moving load is located, okay? And you can then also see more results if you wanted to see draw moment diagrams, let's say, or the shear force diagrams in this case. You can see that this is Fx. We can see, let's say, Mz variation. So this is actually going to show you the moment diagram as the moving load moves along this structure. So if you click on stop, it'll stop the animation. You can just go back and click on this button called redraw solid, or redraw to uh, see the wireframe mode or the solid rendered mode. Thank you for watching this presentation. If you have any questions, please feel free to contact us. Thank you and have a nice day. Bye-bye.